This is Dashadhar K. Back to you with the GATE 2022 Theory of Computation questions in the GATE examination. If you look at your 2022 GATE question paper, we have got about 5 questions, out of which 2 are from the 1 mark questions and 3 for the 2 marks questions. Altogether, this course has got about 8 marks. This is the normal weightage we have for any competitive examination for this particular course. 8 marks has got it from this 2022 GATE. If we do the analysis of these questions, see all 1 mark questions as well as the 2 mark questions, all are the multiple choice questions or multiple selection answer questions. Surprisingly, this year you didn't get here any kind of numerical answer type questions. Usually we can have one numerical answer type question on this, but this time we had most of the questions from the multiple selection answers, MSQs, and we seen here only one MCQ, that too from the finite automata concept, and other 1 mark question is from the properties. The remaining questions also we have one question from the decidability concept, undecidability, decidability mechanism. So there is a one question on the MCQ for the undecidability concept, and there are 2 more questions on the language determination. This language determinations also they are given the priority for combination of the languages, regular languages and context-free languages. They combined various kinds of formal languages, and questions are formatted for the recognition of it. And surprisingly, they are also mixed the closure properties of the formal languages. And each and every formal language like regular, deterministic, CFLs, non-deterministic CFLs, we have here different kinds of formal languages. For those languages, properties has been included into the options. So I would say this time majority of the students has felt they are not have the difficulty to answer, but when you look at the options, the problem is here when you have the options has made them to confuse. What are the objective of the examiner wanted to test the student skill set? Whether you wanted to check really the creativity of the problem solving, or really you wanted to check the intellectual way of the student to solve the problem. We are not find here what actually the examiner wanted to do by looking at these questions, because the student has not felt anything like difficulty for solving the problem. I understood here the students has faced the problem here to identify selection of the answers. What we found here, they know the answers. The problem they have faced here among the given options, what is the appropriate? Because certain options has made them to think, confuse, or made them to the confuse, or some of them are kept here. What is the approach, or what is the examiner really wanted to identify from this particular question? As a professor, I also have your same kind of feeling. The professors who have said this question, I have the strong opinion that we are not actually the given these kind of questions to 2022 from this course like formal language and automata theory, not to test the intellectual capabilities of the candidate, or problem solving capabilities, or computational thinking capabilities. You have tested the students actually to make what is the appropriate combination of the answers. Student has spent a lot of time on combination of the options, not on the problem solving. So that is what our strong opinion on that this particular course, especially in 2022 formal language and automata theory. Let's have the questions what they are given in the 2022, and just look at what the problem statement and what are the different kinds of solutions for them. Just have the first question. Which one of the following regular expressions correctly represents the language of the finite automaton given below? This is a this is a question of the multiple choice question. So there is only one answer here. This is the finite automata they are given, and these are the different options we have with us. We have to figure it out what is the regular expression representing this finite automata system. We have option B, this one. Option C is here A B star B plus B A star A and whole star, and A star plus B star, and we have the D B A star A plus A B star B and whole star, and A B star plus B A star. So these are the four options we have here. We have to identify what is the regular expression represent this finite automata. We know whenever we have here such a questions, you can easily attempt by approach called here verifying the equivalency of the languages. We just look into the equivalence of the languages. What is this automata can accept, and what is this expressions can generate? The generated expressions, language, and language accepted by this automata must be always identical. If it's identical, then we go for that is a right choice for us, right? So this one you need to apply any kind of procedures to answer this question. That's the reason actually they might have given for the 1 mark. Why? Because if we go for application of any procedure, say application of your state elimination method to derive the expression, or you maybe go for getting the expression using the ordinance theorem, you can apply and then get the solutions, but there is no guarantee that can match with your options here. Reason behind that, you don't have your unique expression for any of the language which is recognizing by the finite automata system. You maybe have the different answers, or you can say different solutions. Solutions in the sense the expressions will be always generating the same language, but representation of the expressions can be the different formats. That's why you may not be getting about the same expression for each and every approach. So approaches you maybe have the different, then expressions also may be different, but you can have the same language. That's the point here. So we are just observing about the point. Look at this and identifying the strings here. I just do this simple approach. You just watch it. Look at this automata here. I would say here this will accept the first string. The first string you have to understand. The first string it is going to be accept here singly A. All right. After that, you should take here 1B also being accepted here. Got it? Later on, this is going to be accept here. AB will be accepted as well as the BA also will be accepted. So you can see this is the pattern of the string for this language. Now I am just getting into these options. How I going to eliminate? You will just look at here. If we look at this option, what you can understand? I should select always either of this portion or this portion. If I see this very first string, I can have it from the option A. This is ABA is the very first string. Or else you can have here, this is a BAB is the another string. Option A I can easily eliminate because there is a mismatch. Very first string of this language is a L, is got a, but I don't have here same A. This is the minimum length is here 3, there I have the minimum length is 1. That's the reason we can eliminate here option A. Option A you can be remove of it. Then come to the option B. In the option B, if you look at, we may have the similarities same to this language, but another point you have to understand, Still, is it going to be generate here all the strings language members what we are allowed to have it? Say for example, from here you can check for the AB, then B, A. I take down here, it's going to be accept like A, B, B, then A, B. I have this kind of thing. Or else you can also try for one more time, same, I can have here AB, then AB I can have it. If I would take this portion here, this is going to give me like AB part. Then if I do repeatedly also, I can have here once again AB and AB, AB. But there may be the combinations which I wanted to take like a B, A, B and so on, other combinations. If we look at this kind of particular string here, you know, this is going to be take B, A, then we can have here A further and again this. What happens here, you just understand, this is always going to tell like end with either A, B star, or this is saying about the B, A star. But you remember, this is again coming back to this place. It should be the any number of times I may be rotate here, again I may come back to this one, I can rotate for the any number of times. It should be like a combination of whole star. But this is saying here either of this portion or this portion. It is not going to take the holistic of the expression like a whole star will not come here. This whole stick of thing is whole star will not come here. That's why this may be talking about with respect to one area this or with respect to this. But the composition of these combinations also will be valid. That's why we are not even not going to the option B also. Then when I talk to you about the option C, you know, option C may first string I can generate epsilon here. I can generate epsilon. But from this place, you cannot have the first string as epsilon because the first string is accept here A. That's why this C option also we are avoiding because this will produce here epsilon. That's why option this one also wrong here. Then finally, what is the only possibility for us? You know, this is the expression will give us exactly the same well. And moreover, you know, this is the whole star we have and it has been ended with here always either this portion or this portion. That is going to be exactly represent about this cycle format. That's the reason we are just finding out or we are going to be tracing out the right answer of this question as a single. That's about only option D. This is your MCQ. So this is the multiple choice question. So right answer is here D. So that's what you can understand from this answer. But if you apply ordinance method, I say if you apply the ordinance theorem, you can directly generate the same expression. You can directly generate the same expression. Right? Apply the ordinance theorem, you can directly get this expression. Straight away you'll get it. But what I am suggested here, for exam perspective, there is no point here to application of the procedures. It's the time to check out answers much smarter way. So this is the best way to answer this kind of questions here. So let's look into the second question of the 1 mark. This is the question actually based on the properties of the recursively enumerable languages and deterministic context-free languages. So as I said this time they combined all kind of formal languages and they are asked for their closure properties. Just look at the question, which of the following statements are true? So this is the multiple selection answers, selection questions. So you should understand there are multiple answers are here. First option is here, every subset of a recursively enumerable language is recursive. Option B, if a language L and its complementation L are both recursively enumerable, L must be recursive. So I just repeat this, if a language L and its complementation L dash, I would say here L dash, are both recursively enumerable, then L must be recursive. Good. Then option C is complement of a context-free language must be recursive. And option D, if L1 and L2 are regular languages, then L1 intersection L2 must be deterministic context-free language. So this is what the 4 choices we have. We have to figure it out what are the true statements of this. And we know the relationship among all these languages. What the relationship you could say here? We know the biggest set among all the formal languages is the recursively enumerable languages. Within that we have the recursive languages, that's the rec is there in the set. After that you also have within this context-free languages are there, it's a CF. Further within this you can say that there are a DCFLs here. Within the DCFLs again we have about the regular languages. I would say in the DCFL again there is a one more subset that is about the regular. So the first thing is regular, on top of it we have a DCFLs, on top of it we have a CFLs, on top of it we have your recursive languages and then recursively enumerable languages. And when you talk about the properties, you all must remember about the standard properties and most important properties of each and every language what is listed here. When you talk about regular languages, there is no specific property to be remembered with respect to the closure properties. If we feel that base languages, suppose they are regular, by default its operations like a union, intersection, concatenation, all are by default regular languages. That's a basic property. Subset, each and every subset of a regular is not necessarily be a regular, that's a different property. But the standard closure operations whatever we have, you should understand applicable for all the closure properties of the regular languages. If base languages are regular, by default all its operations are also regulars, right? That's the one thing you have to remember. And let's come to the context-free languages. Before of it there is no DCFL. On the top of the regular there is a DCFL. Later on top of it we have a CFLs. When you talk about the DCFLs are actually not closed under the intersection, but they are closed under the complementation. And we talk about the context-free languages, there are 3 properties you have to remember. Context-free languages are not closed under the complementation and they are also not closed under the intersection, but they are intersected with the regular languages. So they are the 3. And you go to the recursive languages. Recursive languages point of view, there is a one important thing you have to remember. They are closed under the complementation. They are under the complementation. On top of it we have here recursively enumerable. I written this set only with respect to this options. I have not written here in between like any kind of context sensitive languages as not inserted in this box. I just concentrating on this prospect like options. So that's the reason I just added about this. So fine. So when you say about the recursively enumerable languages, they are not closed under complementations, right? So they are the basic properties, we are all aware about it. Now you just watch the options and tell me the right possibilities. Every subset of recursively enumerable language is recursive. Recursion is the subset of REL. Every subset of the recursively enumerable language is recursive. That is the statement is saying, which means there may be your certain L1, L2, L3. All are recursively enumerables. Every language whatever you have in this area recursively enumerable. There may be also L subsets of each other. L1 may be the subset of L2. Though they are recursively enumerable, there is also possibility for here L1 can be the subset of L2. E says that every subset of, that's the point here. Subset of recursively enumerable language is recursive has a different meaning. You remember particularly this course, the verbal English or you can say the vocabulary is very, very important. Every subset is saying that. Every subset is not necessary. There may be the certain subsets, maybe also Recursively enumerable, not necessary. But every subset of recursive language is by default recursively enumerable. That is true. Every subset of recursively enumerable recursive language is a recursively enumerable. But this is reverse. Every subset of recursively enumerable language is not necessarily be a rec. It may be, may not be. That's why we are going for here option A is not the true statement, it is a false statement. Then we also have the general statement as what here? RELs are not closed under complementation, but recursive languages are closed under complementation. What is the meaning of it? If L1 and L dash wanted to be recursively enumerable, it possible only if L is recursive, because L and L dash both are suppose recursively enumerable, right? Definitely you should understand that rec is the only possibility because of recursive languages are closed under complementation part, but whereas this is not closed. That's why we take here the option B. If the language L and its complementation L dash both are recursively enumerable, if it's wanted to takes place, it must be recursive. This is the true statement. And complementation of a context-free language must be recursive. This is also true. This is also true. Why? Because context-free languages are not closed under the complementation. If they are not closed under complementation, it should be in the next level. The result should be what? It should be in the next level. When it comes to the next level, what happened here? It should be true because recursive languages are closed under complementation. That's why this statement is also true. And come to the D, L1 and L2 are regular, then L1 intersection L2 must be deterministic context free, right? If I take L1 and L2 regular and its intersection is also regular, its intersection also regular, right? Every regular is also subset of the DCFL. Every regular language generally will be recognized by what here? Deterministic PDA. Languages recognized by the deterministic PDA, we call them as deterministic context-free languages. So therefore, option D also true statement. There are B, C, D. 3 statements are here correct here. So that's what we can understand here. B, C, D are the correct answers. So they are the statements like a B option, C option and D option are the true statements for this second question. So the next we have about the 2 marks questions here. The first question on the 2 marks, as for the question paper which has started at the question number 46 onwards, 46, 47, 48, these are the questions under the course of formal language and automata theory. Just look at here the first question of the formal language and automata for the 2 marks in the 2022. This is the question actually they formatted using the concept of undecidability mechanism. Just watch it, the statement of the problem. Which of the following is or are undecidable? Option A, given a Turing machines M1 and M2, decide if L of M1 is equal to L of M2. And we have the statement number 2, that is option B. Given a Turing machine M, decide if L of M is regular. And statement number 3, given a Turing machine M, decide if M accept all strings. And D is what here, given a Turing machine M decides if it takes more than 1073 steps on every string. Here there are 2 parameters you have to check it. If any time if a Turing machine halts on every string, we should consider it as a decidable one. Why? Because the Turing machine is always halt for the recursive languages. Recursion is the alternative name for the decidability. So by default, every recursive term I must consider it as a decide. It must be decide. If it is a recursive language, what happened? For each and every string, machine is going to be eventually halts. If machine eventually halts, then you should take it as a decidable problem. As far as the statements, what is given here, they are the standard statements, or you can say they are the what do you say? They are the general theorems which we have in the formal language and automata concepts. All the things. Language accepted by the Turing machine, we can say that is recursively enumerable language, or else I can say that it is a recursively enumerable or recursive language. In general, we'll say that if something is recognized by the Turing machine, we will say it's a recursively enumerable. But you cannot fix whether it's a regular language or whether it's going to be context-free language. That part you cannot decide. So languages accepted by Turing machine, we can't guarantee all the time it's going to be the regular. We cannot guarantee. So that's why languages accepted by Turing machine deciding it is a regular is a undecidable statement. Even for the context-free language also undecidable statement, that's not possible. And equivalences of the Turing machines. Generally, we have about the equivalences. Non-deterministic machine I can convert to the deterministic machine, and I can convert here multi-tape Turing machine to the single-tape Turing machine. That kind of conversions are possible, but verification of the two languages equivalency. Even you take down languages of the context-free grammars. There are two grammars like a G1 and G2, right? Verifying language of G1 and equivalency of the G2 is a not possible task. We don't have here any specific algorithm to decide it. That's why same property you can take it. Instead of asking for the languages, he is asking the languages of the Turing machines here. So equivalency of the languages by accepted by two machines is not possible to be decided. We don't have any specific algorithm for them. So that's why in these questions you can see the statement A also undecidable, statement B also undecidable, and this C statement is nothing but acceptance of a W by the Turing machine. When you give W to the Turing machine, we cannot guarantee where it's going to be terminate, does not terminate. To say it's a decidable, it must terminate. That's the point here. So for all strings, when I gave to the W to the Turing machine, it can be like combination of the L values or it can be the L dash values. For L values, it may be terminate, but L dash values may be terminate, may not be terminated. So that's the reason actually what he is saying. Acceptance is always subject to the what here, the language. For L values, it's going to be always going to be accepted, but L dash values also we have to decide. So the statement of the problem here, a given Turing machine M decides if M accept all strings. All strings, it is the ingredient of L members and L dash values. That's the reason we are just picking up here option C, also undecidable statements. Altogether for this problem, statement A, B and C are the undecidable problem statements of this, right? So next question is on identification of the language. So let's see here what are the languages they are provided here, and then check out what kind of languages they are. Take the statement, consider the following languages, L1 equivalent to A power n W A power n such that W belongs to A comma B whole star and L2 is equal to another language, it is a WX W power R. This is the one of our standard language and little critical important language, and A comma B whole star, but length of the W and X is always greater than 0. Note that W power R is reverse of the string W. Which of the following is or are true? We have option A, L1 and L2 are regular. Option B, L1 and L2 are context free. Option C is here, L1 is regular and L2 is context free. And D, L1 and L2 are context free but not regular. So there are the four options we have with us. We have to check it out what is the relevant statement for the L1 and L2. First of all, you have to check out here what the L1 and L2. If you see the L1, right, what you can understand, this seems to be like regular language. They are given the n. The problem is they are given the n. What is the meaning of the n? That also you must be specified. I sincerely look for here what is the n value. So as a given n, if they wanted to consider as a natural number like a n, they should kept here like a capital N, or if they written here lowercase n, they must have given some specifications of it. So when it comes to this particular course, the notations are pretty much important. If they don't give the specifications, how we can make our own assumptions? So it should be generalized one, or it should be the thing to be validated across the globe. Everybody should be in a position to recognize that. Then it's going to be the justification for the student. That's what I told. They're given the n, but n, what is n? I just take here my n can be what? Natural number. If it is a natural number, I would say it will start from here 1 to 3. Or else can I take my n is equal to 0? That is also possible. As he is not mentioned. If he is not given, say for example, n is equal to 0, I would say, then this w is equal to what here? A plus b whole star. It's a by default regular expression. It's a regular expression. Got it? So this regular expression, once I generated for language, then it comes under the regular language. It comes under the regular language. Whatever string you wanted to have from this language, by assuming my n is equal to 0, I can have it from this expression. Obviously, you can generate it. Okay, if that is not scenario. For example, he mentioned it's a natural number. Let's go for the 1, 2, 3, 4, 5 and so on. If I take that, I wanted to have the other combination like a, then that is possible if I take this. Then also I'll get a pattern of like a even number of a's kind of strings will be coming over there. For that combination also I can definitely have a regular expression. Hence, I consider whatever may be the n value, for that my L1 can give you always some expression. That's what this is by default regular. It's a regular. And this is very much important language for all of us. Very popular language. It's like appears palindrome kind of thing, but actually this is not. This is the very popular language as a regular, because this will always produce all the sentences which start with the same symbol and end with the same symbol. That is the language. Why? Because length of this one is greater than 0. Whatever string I may have it in between, that you can generate from the x, but before of it I must have a w, after that I must have a w power r. This is going to give you like 0 into 0 plus 1 whole star into 0, or it can be 1 into 0 plus 1 whole star into 1. So this is what the expression of this language. This can be described as what here? All the sentences will begin and end with your same symbols. So there are two choices, one with start with 0, other one you can start with here 1 and end with the same one. So these two are regular languages. That's fine. Identification of that itself is a complex task. Now what making in this one, because of the MSQ, options are making the confuse. We also have here pretty much idea. You know that this is a L1 and L2, both are regular, yes. And you wanted to take it as MSQ, L1, L2 both are context free. What is the point here? If I conclude something is regular, is a by default context free, right? If I stand for only context free, then it may not be regular. That is what generally. It may be regular, may not be regular. So let's assuming that okay, his intention is to what here wanted to go for the B, because L1, L2 also context free because of they are regular. This is also possible. But this option is little bit confusing. L1 is regular and L2 is context free. If both are takes place regular, as this is given as a true statement, then there is no meaning of having up the option C, my opinion. That is not going to give you any creative or you can say subject matter for the student. to test the student, what do you call, computational abilities. My perspective, it doesn't going to be help for the student to we to identify what is his computational thinking capabilities. It's the only thing to make him confused. You said that this is okay, true statement. This is also true statement. Again, okay, high. But this is some options they are being given here intensely to make them no confused. But in fact, I would say A okay, B okay. Then this is automatically there is no point here to keep it. If they wanted to give, they can give something more. But anyhow, in the official key, they released this one as also true. This one also true. So okay, that is also obviously true because of these are regular. It can be true. This is also can be the subset. That's the reason you can say that it also can be true. As this is true, this is true. This option is one from here, one from here. But that is not helping actually to check the student capabilities. I mean problem solving capabilities. That's the point here. So obviously he has also given this one also is the right choice. So that's what I said. Many of the students has got confused because of these combinations. Fine. But L2 and L2, L1 and L2 are context free but not regular. This is the false statement. If this statement, I love it because they are given the very clarity about the statements. So they are mentioned in the key, but actually I am not happy with the option C, but the option A and B is very clear, okay. But this is wantedly they made it. So that's what I understood. Then finally I could say these answers are going to be like only A, B is my point of view. The question and answers can test the real abilities of the student, but this is the question they are given purposely to make the student confused, not to test the abilities. So, but option they are given in the official key, this is like a B, C, right? So this is the answer as for them. But my point of view, I really oppose option C statement because there is no meaning here to taking off all of them. So A, B is my perspective. That's what I highlighted. But they are given the option C as a also as the member. Okay, their perspective is maybe right. I'm not saying it's not wrong. It's right, but it's not going to be take the creativity of the student to the out by solving this problem. When they're given here such a beautiful question, when I look at the L1 is such a beautiful question. They are done a fantastic job to create that question. So that's what my understanding from here. This is the answer for the actually AB, but they're given it as a ABC. Their point, their perspective. My perception is here only AB is enough. C is they're given it as no to make the people to confuse. That's what I that's my perception, right? So this is the answer for the 4. Good. So next question also given here to identify the language of the given set of languages. So let's see the statement of the problem here. Consider the languages. They are given about the 3 languages L1, L2, L3. And which of the following statement is or are false? Option A, L1 is not context free, but L2 and L3 are deterministic context free. And option B is neither L1 nor L2 is context free. C is L2, L3 and L2 and intersection L3 are context free. D is neither L1 nor its complementation is context free. So I love this time the first question what they are given. This is a very popular language, that is about the copying of the strings. Whatever you have a W, that W should be again further copied in the next word. It's a copy problem and very popular language which is being recognized as a context sensitive language. Context sensitive language. And L2, L3 they are very popular languages like they are equal number of A's followed by equal number of B's followed by any number of C's. Same thing like a L2 and L3. So any number of A's followed by here equal number of B's and C's here. These two are very popular languages. We will say this is a context free, this is also context free, right? And you know that this is not a context free, this is a context sensitive. This is what the fact known. Just see the options. What I mentioned, option A, L1 is not context free, but L2, L3 are deterministic context free. Is asking for here false statement. L1 is not context free. That's absolutely right. That's absolutely right. and L2, L3 are deterministic, and moreover both the CFLs, moreover this is a DCFLs. DCFLs. We can have a deterministic push down automata for both the languages. So that's what option A is true. But we wanted to have only false statements. So this is a true. B is neither L1 nor L2 is context free. Neither L1 nor L2 is context free. So this is also false statement because both are here. Neither L1 nor L2 is context free. L2 is context free, but L1 is not context free. So here this statement is also false statement. And L2, L3 and L2 intersection L2 are context free. But this is L2, this is L3, both are context free, this is valid. But L2 intersection L3, if I take this intersection part of this, it will give you the language here A power n, B power n, C power n such that n is greater than 0. This is the language we are going to have it. This language, this is a context sensitive language. This context sensitive language. So therefore, this is also false statement because these two are true, but this is not true. And this is intersection is what? A context sensitive. And neither L1 nor its complement is context free. That's the question he has given here. L1 is not a context free. We are all agree about it because it's a context sensitive. What about its complementation? The complementation of it, this will be give the language of this. If I take whole star, A I can have, B I can have here, right? I also can have AB I can have, BA I can have, you remember, and all such strings I can generate from that. All these strings you can generate it from the context free language or context free grammar. You can generate it from the context free grammar. So complementation generate here this kind of language, and everything length 3 also will be generated. All of them you can generate here. You can generate complementation of this L1 by the context free grammars. Hence complementation is a context free. But D statement he mentioned here, it neither of the L1 and its complementation is a context free. That is a true statement he has given. So that's why this is the false. If this is the standard statement like a context sensitive language statement, if L is a context sensitive and its complementation, usually what happened, we have seen many of the books, it is like a still open question. Some people are saying that it's a complementation is also closed under the complementation. But sensitive languages are actually, as of now, we understood that still it's an open question because it has not been published into any of the standard books, or it's not endorsed by the many of the people. If they are endorsed, then it should be published and same thing should be supplied to all the universities. But some universities or some of the premium institutions are saying that, okay, some professors are saying that it's solved or it's been proved that it's a closed under the complementation. But we are not seeing here any kind of evidences in any standard book. But we consider the reason for that, unless it has been published and endorsed by someone, we don't stand for the statement, but we just believe it's happening. This is also, this complementation story of the L1, it is coming to the light in the 2012. I see the first paper in the 2012. Then in 2016, some of the people has been published the new grammar for that. So that's how we all come for the conclusion, okay, its complementation is here, its complementation here context free. That's the reason they have given here, that's D as the answer. It's a beautiful question. It's a beautiful question about this option. Really, unless the guy aware about this new language complementation, he cannot answer. So that's why I love this question like a L1, especially the L1 complementation, everybody having about the query, what is happening. So this is actually context free language, right? So right answers of this question is here. As for the statement, false statements are B, C, D, all are here false statements. So we can take here, all are here false statements we can take in this list. So these are all they are given in the GATE 2022 from the course of Formal Language and Automata Theory, or else the Theory of Computation, right? So this is your Dasha sir. We are officially signing off for this 2022 GATE solution details.